Welcome to my YouTube channel. Myself Ujjal Baro. This is the part 1 lectures on the environment. The word environment is most commonly used to describe nature and means the sum of all living and non-living things surrounding an organism or ground of organism. So these are the content that I have to discuss in this presentation. So first is the introductions about environmental educations, definitions of environment, objective of environmental studies, why we need to study environmental science, scope of environment, multidisciplinary nature of environmental science, principles of environment, structure of environment, layers of atmosphere, and compositions of atmosphere, and different environmental celebrations and their dates. So environmental educations. So there is a definition that is given by Tbilisi declarations in the year of 1978. So environmental educations is a learning process that increases people's knowledge and awarenesses about the environment and associated challenges, develops the necessary skills and expertise to address the challenges and fosters attitudes, motivations, and commitments to make informed decisions and take responsible actions. Then, according to UNESCO, environmental education is a way of implementing the goals of environmental protections. It is not a separate branch of science but lifelong interdisciplinary field of study. It means education towards protections of enhancement of the environment and education as an instrument of development for improving the quality of life of human communities. So, definitions of environment. The word environment is most commonly used to describe nature's and means the sum of all living and non-living things surrounding an organism or group of organisms. The environment includes biotic means the all surrounding living organisms, and abiotic factors, that is light, temperatures, water, atmospheric gases that influences observed organisms. In a nutshell, the environment is the total of all the conditions, physical, chemical, biological, social, cultural, and economic, surrounding the human being at a given point in space time. The term environment is used for surroundings and is derived from French word environ or environner, which means around or encircle or surroundings. The environment may be defined as the complex of climatic factor means to any weather related conditions such as temperatures, perceptions, humidity, and wind that affects living organisms and their environment. Then biotic factor refers to any living component in an ecosystem such as plants, animals, bacteria, and fungi that affects and interacts with other organisms. Then social factor. In the perspective of the environment, a social factor refers to human activities and social influence such as population growth, urbanization, cultural practices, and economic policies that impact environmental conditions and ecosystem. Then edaphic factors refers to any soil property, physical, chemical, or biological that influence living organisms, especially plants, that act upon an organism and determines its form and survival. Then the environmental science can be defined as an interdisciplinary study of how the arts work, how we affecting the Earth's life support systems, and how to deal with the environmental problem we face. This means that environmental science integrates knowledge and methodologies from various disciplines such as biology, chemistry, physics, geology, and social science to understand the complex interactions within the Earth system. It examines the natural processes that sustain life on our planet, including the cycling of nutrients, climate regulations, and ecosystem dynamics. Furthermore, environmental science investigates the impact of human activities on these natural systems. This includes studying pollutions, deforestation, climate change, and resource depletions, among other issues. By understanding these impacts, environmental scientists aim to develop sustainable solutions to mitigate or reverse environmental damage. This involves proposing strategies for conservation, pollution control, sustainable resource management, and advocating for policies that protect and restore natural environments. Then the environment is constituted broadly of two components, that is the non-living or physical, then the living or biological. In non-living or physical includes air, water, soil. Then in living or biological consists of plants, microbes, animals, humans, etc. Then the objective of environmental studies. So it includes awarenesses about the environment, educating individuals about the environment and its components such as ecosystem, biodiversity, and natural resources. For example, teaching students about local wildlife and plant species through field trips and classroom activities. Awarenesses about the environmental challenge, making people aware of the issues affecting the environment such as pollution, climate change, and deforestation. For example, organizing seminars on the impacts of plastic pollution and ways to reduce plastic use. Then to develop the necessary skills and expertise to address the challenges, equipping individuals with the skills and knowledge needed to solve environmental problems. For example, providing training on renewable energy technologies and their installations. Then aims to teach how the natural environment functions and how human beings can manage behavior and ecosystem to live sustainably. Understanding ecological process and learning how human activities can be aligned with sustainable practices. For example, implementing community projects that promotes sustainable agricultural practices. Then educations towards protections and enhancement of the environment, encouraging proactive measures to protect and improve the environment. For example, starting a tree planting campaign to restore deforested areas. Then to implement the goals of environmental protections and conservations, putting into action specific strategies aimed at conserving natural resources and protecting ecosystem. For example, enforcing laws that limit emissions from factors to reduce air pollution. Then the last one is to foster attitudes, motivations, and commitments to make informed decisions and take responsible actions, developing a mindset that values the environment and motivates individuals to make decisions that benefit it. For example, encouraging individuals to reduce their carbon footprint by using public transportations and supporting green policies. So, by achieving these objectives, environmental education aims to create a more informed and responsible society capable of addressing current and future environmental challenges. Then why we need to study about the environmental science? So studying environmental science is essential to understand and mitigate human impact on ecosystem, promote sustainable development, address global and local environmental issues, and inform public awarenesses and policy. It integrates knowledge from various disciplines to develop effective solutions for environmental challenges. This field is crucial for creating resilient resilient communities and ensuring a sustainable futures for all. So first one is the understanding human impact on the environment. The study of environmental science is crucial for understanding the profound impact human activities have on the planet, as highlighted in human populations dynamics, economics development, rapid urbanization, and technological innovations are major drivers of environmental science. By studying these interactions, we can assess how our actions alter the atmosphere, hydrosphere, lithosphere, and biosphere, leading to issues such as pollution, climate change, and biodiversity loss. Multidisciplinary natures of environmental science. Environmental science is inherently multidisciplinary, integrating knowledge from biology, chemistry, physics, geography, economics, sociology, and law. This comprehensive approach is necessary to address the complex and interconnected natures of environmental problems. For instance, understanding the biotic and abiotic components of ecosystems require insights from life science and physical sciences, while effective environmental management necessitates knowledge of economy and sociology. Then addressing global and local environmental issues. Environmental science equips us to tackle both global and local environmental issues on a global scale. Issues such as global warming, ozone depletions, and marine pollution are paramount importance. Locally, problems like deforestation, soil erosion, and water pollution directly affect communities. By studying these issues, we can develop strategies for mitigations and adaptation, ensuring the sustainability of our natural resource and ecosystem. Promoting sustainable development. Sustainable development is a key objective of environmental science. This involves utilizing natural resources in a way that meets current needs without compromising the ability of future generations to meet their own needs. Environmental science provides the knowledge and tools to implement practices that minimize environmental degradation, promote the conservation of biodiversity, and ensure the equitable use of resources. So in coming videos I will discuss broadly about sustainable development, then enhancing public awarenesses and policy. Public awarenesses and effective policy making are critical for environmental protections. Environmental science plays a vital role in educating the public about the importance of the environment and the need for sustainable practices. It also informs policymakers by providing scientific evidence and recommendations for regulations and policies aimed at environmental conservation and pollution control. Then responding to environmental hazards and disaster. Environmental science helps us understand and respond to environmental hazards and disasters. By studying natural processes and human-induced changes, we can better predict, prepare for, and mitigate the impacts of events such as earthquakes, floods, and industrial accidents. This knowledge is essential for developing resilient communities and reducing the risk of environmental catastrophes. So in the conclusion, we can say that the study of environmental science is essential for understanding the complex relationship between human activities and the environment. It provides a comprehensive framework for addressing environmental challenges, promoting sustainability, and enhancing public awareness and policy. By integrating knowledge from multiple disciplines, environmental science helps us develop effective solutions to protect our planet and ensure a healthy and sustainable future for all. Then the scope of environment. The scope of a subject defines the extent, boundaries, and range of topics covered within a field of study. It includes key themes, the level of detail, practical applications, historical and future perspectives, and methodologies used. So, in the diagram represents the various components and focus areas within the field of environmental studies. So let's discuss one by one. This is the geo ecosystem. So this refers to the study of ecosystem at a geographical scale, integrating the interactions between living organisms and their physical environment. For example, studying how different landforms like mountains and plants influence the types of vegetations and wildlife that can thrive in those areas. Then functions of ecosystem. This involves understanding the processes and functions that occur within an ecosystem, such as energy flow, nutrient cycling, and food webs. Examining how, for example, examining how plants convert sunlight into energy through photosynthesis and how this energy is transferred through the food chain. Then environmental hazards. This area focuses on the study of natural and man-made hazards that pose risk to the environmental and human health. For example, investigating the impact of natural disasters like earthquakes and floods, as well as human induced hazards such as oils spills and industrial pollutions. Then management of environment. This involves strategies and practices aimed at managing natural resources and environmental sustainability. For example, implementing conservation programs to protect endangered species or developing policies to reduce carbon emission. Then ecological studies. This field focuses on the relationship between organisms and their environments, often at a detailed or local scale. Studying the interactions between bees and, for example, studying the interactions between bees and flowering plants in a specific regions to understand pollination dynamics. Then pollutions. This area deals with the sources, effects, and control of pollutants in the environment. For example, analyzing the sources of air pollution in urban areas and its effects on human health and the environment, along with measures to reduce emissions. Then main environment processes. This examines how human activities affect the environment and how environmental changes impact human societies. For example, investigating the effects of deforestation on local climates and biodiversity and how these changes affect agricultural productivity. Then global environmental problems. This focuses on large scale environmental issues that affect the entire planet. For example, studying climate change, its causes such as greenhouse gases emission, then its global impacts and international efforts to mitigate its effects. Then last one is the evolutions of plants and animals. This area explores the evolutionary process that have shaped the diversity of life on Earth. For example, researching how certain plant species have evolved to survive in arid environments or how animals have adapted to changing climates. So these are the scope of environment that we have to study. Then multidisciplinary nature of environmental science. So environmental science is a multidisciplinary or interdisciplinary subject that deals with every aspects of life. It requires knowledge from various subjects like biology, chemistry, physics, microbiology, biochemistry, statistics, geology, economics, management, law, sociology, etc. So let's discuss one by one. So life science, including botany, zoology, genetics, ecology, biochemistry, biotechnology, microbiology, etc., help understand the environment, biotics, components. Then physical science, including chemistry, physics, geology, atmospheric science, oceanography, geography, etc., provide knowledge of the physiochemical structure of the environment's abiotic components. Mathematics, statistics, and computer science serves as effective tools in resource management. Then social sciences like economic sociology, management, and mass communications furnish inputs to deal with socio-economic aspects associated with various developmental activities. Then the synthesis of civil engineering, hydraulics, chemical engineering, and nanotechnology provides technical solutions to environmental pollution control and waste treatment, which are extremely important for protecting the environment. Then political science and environmental law provide guideline and judicious management tools for effective management and environmental protections. So in this slide I have discussed the multidisciplinary natures of environmental studies that we have to study. Then the principle of environment. This section highlights the basic environmental principles and emphasize our ecosystem because this is the only way our planet can be protected and actions should be taken to solve our environmental problems. The first one is nature knows best. Concepts of environmental science. Human must understand nature and follow its rules to ensure a continuous and steady supply of resources. One must not go against natural processes. If any disruptions is caused in the cycle of nature, this can bring imbalance to our ecosystem. For example, crop rotations in agriculture. By rotating crops, farmers can reduce the building of pests and disease that occur when one type of crop is planted repeatedly. This practice mimics the diversity found in natural ecosystem, leading to healthier soil and plants. It reduces the need for chemical fertilizers and pesticides which can harm the environment and human health. The next, all forms of life are important. Its organisms plays a fundamental role in nature. It is easy to appreciate beautiful organisms like butterflies, especially if one knows their important role in pollinations. The giant one like elephants, whales and alligators are the ones who we respect mixed with fear or wonder and their products. But when it comes to unlovely, screamy and troublesome creatures, this principle is usually overlooked. For example, bees and pollination. Bees are vital pollinators for many crops. Without bees, many plants would be unable to reproduce, leading to decreased food productions and loss of plant species. This could have a cascading effect on the entire ecosystem, affecting other species that depend on this plant for food and habitat. Then the next principle is that everything is connected to everything else. In an ecosystem, all biotic and abiotic components interact to ensure that the system is sustained. Any intrusion from outside may cause an imbalance and collapse of the ecosystem of the system. For example, food chains and ecosystem. In a forest, plants producers are eaten by herbivores, that is primary consumer, which are then preyed upon by carnivores, that is secondary consumer. If a key species such as a top predator is removed, it can lead to an overpopulation of herbivores which may overgraze and damage the vegetation, affecting the entire ecosystem's health and stability. Then everything changes. The environment is continuously changing. Organisms also develop through time. However, these natural changes have affected these changes with our current technology now cause problematic events for us. Humans should rethink their relationship within the environment, because our belief that it is beneficial to the environment often turns out to be catastrophic. For example, climate change and its impact on ecosystem. Rising global temperature due to human activities are altering habitats and weather patterns. Species that cannot adapt quickly enough face extinction. For example, polar bears rely on sea ice to hunt seals. As the ice melts due to warming temperature, their habitat shrinks, making it harder for them to find food and survive. Then everything must go somewhere. Everything ends up elsewhere. It does not just disappear. For example, if you throw a piece of candy wrapper away, it disappears but does not cease to exist. It ends up elsewhere. Gases released in the atmosphere may spread, but they will end up a component of the atmosphere and be brought down by rain. Any particular type waste should always be a concern to us. It may be a pollutant or a resources depending on certain factors. Be a responsible persons and throw your trash in a proper place. For example, plastic pollutions. When plastics are discarded, they often end up in oceans where they break down in microplastics and are ingested by marine life, causing injury or death. The Great Pacific Garbage Patch is an example of how plastic waste can concentrate in the oceans, creating vast areas of pollutions that affect marine ecosystem and biodiversity. Then the our is a finite art. Earth's resources can be classified as either renewable or non-renewable. Renewable sources are those that can be quickly replenished by natural cycle, for example water, air, plants, animals, while non-renewable resources are those that cannot be replenished through natural cycle. Although renewable resources can be replenished, it is important to understand that these are renewable only if they are not overused and not destroyed by factors such as pollution. For example, fossil fuel depletions. Fossil fuels such as oil, coal, and natural gas are finite resources formed over millions of years. They are being extracted and consumed at a much faster rate than they are naturally replenished. These depletions leads to energy scarcity, increased cost, and geopolitical tensions over remaining supplies. Moreover, the burning of fossil fuel contributes to environmental issues such as air pollution and climate change. Understanding the need for transforming to renewable energy sources and adopting sustainable practices to ensure energy security for future generations. Then the last one is the nature is beautiful and we are stewards of God's creations. Among all creatures, humans are the only ones man made in God's image and have been given the right to have dominion over all his creations. Being the most intelligent and gifted with reasons, humans can manipulate and create changes in nature for their own advantage. Yet creations exist not be reversed or abused but to be taken care of. Humans cannot exist without nature. They are co-natural with the environment they live in. For example, national parks and conservation areas. Establishing protected areas like Kaziranga National Parks helps preserve natural landscapes and biodiversity. These parks allows people to experience and appreciate the beauty of nature while safeguarding habits for future generations. Conservation efforts reflect our role as stewards of the environment, ensuring that natural resources and beauty are maintained for the benefit of all living beings. So these are the principles of environment. Then structures of the environment. The environment generally represents four spheres: the atmosphere, lithosphere, hydrosphere, and biosphere. These correspond to rocks, water, air, and life. Therefore, the environment can be defined as the study of the earth, air, water, living beings, and their mutual relationships. Let's discuss one by one. The atmosphere is a layer of gases surrounding the earth and retained by its gravity. It reaches over 560 km from the surface of the earth. The functions of atmosphere is the absorbs the sun energy, recycle water and other chemical, work with electrical and magnetic forces to provide weather and climate phenomena, then protects from high energy radiations and the freeze vacuum of space, then scatters blue light, giving the earth a blue halo when seen from space. The compositions of earths are: dry air contains about 78.8% of nitrogen, 20.95% of oxygen, 0.93% of argon, 0.038% of carbon dioxide, and trace amounts of other gases. Contains a variable amount of water vapor averaging around 1%. Then atmosphere protect us by absorbing ultraviolet solar radiations, warms the surface through heat retention, reduces temperature peaks between day and night. Then the boundary of the atmosphere. There is no definite boundary between the atmosphere and outer sphere. It gradually becomes thinner and fades into space. The Karmaman line at 100 km is considered the boundary between the atmosphere and the outer space. Three-fourths of the atmospheric mass is within 11 km of the surface. The components and importance of atmosphere: oxygen, carbon dioxide. Functions involve wind, storms, snowfall, cloud formations, weather and climate. Protects from solar and cosmic effects that I have already discussed. Compositions of the atmosphere: gases and water vapors. The atmosphere is mainly comprised gases and water vapors which vary in amount at different heights. The density of the air at sea level is about 1.2 kilogram per meter cube, decreasing with altitude. The rules of the atmosphere: acts as a reservoir of gases, moderate earth temperatures, absorbs energy and damaging ultraviolet radiations from the sun, transport energy away from equatorial regions, serves as a pathway for the vapor phase movement of water in the hydrological cycle. In the coming slide, we will discuss different layers of environment and compositions of atmosphere. Then the lithosphere, also known as the geosphere, it is the solid part of the earth consisting of the crust and upper mantle. The crust is the earth's outermost layer, varying from 5 to 70 km in thickness, composed of rocks, minerals and soil. The crust is inorganic and composed of minerals. Two kinds of crust are there, continental and oceanic. The crust is constantly moving and its movement causes earthquake. Earth's oceanic crust is a thin layer, dense rock about 5 kilometers thick. The continental crust is less dense, composed of lighter colored rock and varies from 30 to 70 kilometers in a thickness. The crust is made mainly of 8 elements: oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. The oceanic crust has more silicon, oxygen, and magnesium, while the continental crust is rich in aluminum. The crust is chemically and mechanically different from the underlying mantle, generated largely by igneous process where magma cools and solidifies to form solid land. The mantle lies beneath the earth crust, heated by the radioactive decay of elements. It is not quite solid and consists of magma. The convection process causes movement of the lithospheric plates known as plate tectonics. Volcanoes primarily result from the melting of subduct crust material. So that is the lithosphere. Then the hydrosphere. The word hydrosphere is derived from two Greek words, that is hydor meaning water and sphaira meaning sphere. It is defined as the combined mass of water found on, under and over the surface of the planet, composed of all waters on or near the earth, including oceans, rivers, lakes, and moisture in the air, covers about 70% of the earth's surface and provides a habitat for many plants and animals. It contains about 1.36 into 10 to the power 9 kilometer cube of liquid water. The second most common form of water is ice, which is sufficient to raise the sea level by about 70 meters. 97% of the earth's water is in the ocean. The remaining 3% is fresh water, with 3 quarters of this fresh water existing in solid form and ice sheets. Water is essential for life and is a major constituent of almost all life forms. Most plants and animals contain more than 60% water by volume. Approximately 71% of the earth's surface is covered by the ocean, a continuous water body divided into several major oceans and smaller seas. More than half of the ocean areas is over 3000 meters deep. Average oceanic salinity is around 3.5%, with nearly all seawater having salinity in the range of 3 to 3.8%. Major oceanic divisions include the Pacific Oceans, the Atlantic Oceans, and Indian Oceans, the Southern Ocean, and the Arctic Ocean. The equator may further subdivide the Pacific and Atlantic into northerly and southerly portion. Smaller regions of the oceans are called seas, gulfs, bays, etc. There are also salt lakes, which are smaller bodies of land locked salt water that are not interconnected with the world ocean. Then the biosphere. The term biosphere was coined by the famous geologist Edward Suisse in 1875 and defined as the place on Earth's surface where life is dwells. The biosphere began through the process of biogenesis about 3.500 billion years ago. It composed of all living organisms from the smallest bacterium to the largest whale. Most life is found from 3 meter below ground to the 230 meter above the ground and in the top 200 meter of the oceans and seas. The biosphere is divided into biomes inhabited by broadly similar flora and fauna. Biomes are classified based on the climate and geography of the regions. Major biomes include deserts, forests, grassland, tundra, and several types of aquatic environment. Each biome consists of more than one ecosystem whose communities have adapted to smaller differences in climate and environment. The biological manifestations of life is characterized by organization, metabolism, growth, adaptations, response to stimuli, and reproduction. Common properties to most organisms are plants, animals, fungi, protists, archaea, and bacteria. Includes being cellular, carbon, and water-based, having metabolism capacity to grow, response to stimuli, and reproduce the same organism. So these are the structure of environment. Then the layers of atmosphere. First layer is the troposphere. The troposphere is originated from the Greek word tropos, 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 which means to turn or to change. It is the lowest and most dense layer of the atmosphere, beginning at the ground or sea and reaching up to 10 to 12 kilometer, with some variations due to weather factor and thermal convection. It is characterized by a continuous decrease of atmospheric temperature with increasing altitude, and most weather phenomena like cloud formations and thunderstorms occur in this region. The lowest layer of the troposphere from the ground to about 1 to 2.5 km is called planetary boundary layer, where anthropogenic activities cause heavy variations in meteorological parameters such as temperatures and directions, velocity, and relative humidity. Then contains roughly 80% of the atmosphere's total mass and almost water vapor of the atmosphere. Important chemical species include CO2, that is carbon dioxide, then H2O, that is water, then NO2, that is the nitrogen oxide. Exhibits a great deal of particle mixing due to solar heating. Solar heating makes air masses less dense, causing them to rise. As air masses rise, pressure decreases, expanding and cooling them, leading to water vapor condensation or solidification, releasing latent heat that further uplifts the air masses. This process determining the maximum rate of temperature decline with high called the adiabatic lapse rate. The troposphere shows a positive lapse rate. The uppermost boundary is called the tropopause, with its height depending on geographical latitude and weather conditions. So this is the troposphere. Then the second layer is stratosphere. The word stratosphere originates from the Latin word stratum, meaning layer. Life above the troposphere, extending up to about 50 km, characterized by an increase in ozone with a maximum concentration at about 30 km. Though the ozone thickness varies seasonally and geographically, atmospheric temperature increase with altitude reaching 0 degrees Celsius at about 50 km, showing a negative lapse rate. This increase is mainly due to ozone absorbing ultraviolet radiations from the sun. Functions include absorptions, absorption of absorption of ultraviolet rays through the ozone layer, protecting the earth from harmful radiations. About 90% of atmospheric ozone is present in the stratosphere. Ozone concentrations are greatest between 20 and 40 km, ranging from about 2 to 8 ppm. The atmospheric pressure in this layer is about 1 by 1000 of sea level. The stratosphere is almost without clouds due to limited water vapor from the troposphere because of the extremely low tropopause temperature, divided into lower stratosphere with a constant temperatures of about 56 degrees Celsius and upper stratosphere about 20 km, where temperature increase to about 0 degrees Celsius, absorbing ultraviolet radiation. The uppermost portion is called the stratopause, characterized by a temperatures of approximately 0 degrees Celsius and distinguished as the warmest regions between the mesosphere and the stratosphere. So this is stratosphere. Then the third layer is the mesosphere. The term mesosphere is derived from the Greek word meso, meso, meaning middle. The mesosphere extends from about 50 km to the range of 80 to 85 km. Temperature decreases with height reaching 100 degrees Celsius in the uppermost mesosphere. Most meteors burn up when entering the atmosphere. In this sphere, it is the coldest place in the Earth's atmosphere, with a minimum temperatures of minus 100 degrees Celsius at the uppermost boundary. The boundary between the mesosphere and the thermosphere is called mesopause. Then the fourth layer, thermosphere. Thermosphere, named from the Greek word thermos, meaning heat. It begins from 85 to 500 km. Temperatures can rise to 1500 degrees Celsius in this region. The International Space Station orbits are situated in this layer between 320 and 380 km. The boundary above the thermosphere varies in 8 from 500 to 1000 km, exhibits a negative lapse rate and is characterized by the high kinetic energy of gas molecule. Then the fifth layer is the exosphere, the outermost layer of the atmosphere extending from the outer thermosphere known as the exobase at a height of about 500 km to the edge of interplanetary space about 10,000 km, contains free moving particles that may migrate into outer space. The regions where atoms and molecules have sufficient velocity to escape from the Earth's gravitation into space is referred to as the exosphere. Then there are also one layer, that is the ionosphere. The atmosphere ionized by solar radiations extend from about 50 to 1000 km and typically overlaps the mesosphere, thermosphere and exosphere. The ionosphere is an example of plasma, neither gas, liquid nor solid. It is the force that matter and represents 99% of visible matter in the universe. So these are the layer of atmosphere. Then the compositions of atmosphere. The atmosphere is composed of gases such as nitrogen, oxygen and argon along with water vapor. Each component has a specific role. So I have given this table. Nitrogen consists of 78.08%, oxygen 20.95%, argon 0.93%, carbon dioxide 0.035%, but now it increased to 0.038%. The neon consists of 0.002%, helium 0.0005%, then methane, that is CH4, 0.0002%, krypton 0.0001%, hydrogen 0.00005%, then nitrous oxide and N2O 0.0003%, then carbon monoxide CO 0.0002%, xenon 0.00009%, then ozone 3, nitrogen dioxide, iodine, ammonia. We have to test it. Then this is the last slide, which is related to different environmental celebrations and their date. So environmental celebrations and date. So World Wetland Day, celebrated in 2 February. Then World Forest Day, celebrated in 21st March. Then World Day of Water, 22 March. World Meteorological Day, celebrated in 23 March. Then National Maritime Day, celebrated in 5 April. Then the Earth Day in 22 April. International Biodiversity Day, celebrated in 22 May. Then Anti-Tobacco Day in 31st May. Then Ban Mahotsav Week, celebrated from 1 to 7 June. World Environment Day, we all know that is in 5 June. World Ocean Day, celebrated in 8 June. World Day to combat desertifications and drought in 17 June. World Populations Day in 11 July. Ozone Week, 16 to 23 September. World Car Free Day, celebrated in 22 September. Then a Green Consumer Day, celebrated in 20th September. Then World Farm Animal Day, celebrated in 2 October. World Habitat Day in 3 October. Wildlife Week in 1 to 7 October. World Food Day in 16 October. World Conservation Day in 24 October. International Day for Nasal Disaster Reduction Day, celebrated on 13 October. National Children Day, 14 November. World Fishery Day, 21st November. National Rain Resource and Conservation Week, celebrated on 21 to 27 November. World's AIDS Day at 1st December. Global Day Actions Against Corporate Crime, that is Bhopal gas tragedy, at 3 December. International Mountain Day, celebrated on 11 December. The National Energy Conservation Day, 14 December. So I have discussed different concepts related to environmental science. I have discussed definitions of environment, then objective of environment, then scope of environment, then the layer structure of environment, then the layers of environment, different layers of the environment, and then the compositions of atmosphere. So thank you so much.